Question B, Part 1. We have a television safety advertisement featuring a car taking corners at dangerously high speeds. The danger is symbolised by landmines appearing scattered around the corners. As the vehicle approaches a corner, the voiceover says, "There is more force taking you off the road and less force keeping you on it. The car skids across the road and rolls over an embankment. Discuss the accuracy of the voiceover statement with reference to centripetal force and friction." Okay, so we're looking at the accuracy of this statement, and we have to talk about centripetal force and friction. Now, I don't know if you know the ad or not, but I remember it, and I remember thinking similar things watching the ad, so maybe that's a sign when you've become a truly physics geek. Anyway, best approach for this, I think, is to look at the reality, and the reality from a physics perspective. It's also important to note that this statement is set up for the layman to understand and to get a sense of impact. So we shouldn't really knock it too much because it's not trying to be a statement about physics. Yeah, even though it's strictly speaking wrong, which my physics side really wants to rebel against. In any case, if we look at the reality in terms of physics and we compare that to the statement, and there are two parts to the statement that we really want to consider. One part, I'll circle in red or underline in red. It's this more force taking you off the road. That's the first part that we want to deal with, and the second part we want to deal with is this, and less force keeping you on it. Okay, so we're going to consider both of those statements in terms of the reality. So let's look at the reality first. The reality is, whenever a car is turning a corner or anything that's going around in a circle, the only unbalanced force is towards the center, your centripetal force. Okay, so there's no force straight away going outwards. I'm trying not to answer the question as I go through, but there's no force outwards. So what that means is, yeah, the unbalanced force causing the change in direction. The centripetal force maintains the circular motion, and that centripetal force is provided between the wheels and the road surface by friction. So that's the role of friction. There's when friction is when the wheels are not slipping, so as it goes around the curve and it maintains the curve. Oh dear, there's a lawnmower. I'll just pause it and wait. Okay, lawnmower's moving on, hopefully. As it moves around, the car moves around the corner, there's friction, as we said, between the wheels and the road, and when it's not slipping, we call that static friction, and it has a much higher level of friction than when it does start slipping and carrying on in a straight line, and we call that kinetic friction. The mower's back, I'm pausing for a tick again. And the mower's moving on again, I can unpause. Who would be mowing the lawn when someone's trying to record a video? I don't know, the grass doesn't even need mowing. Moving on. So that's the reality of the situation. With the first statement, excuse me, there is more force taking you off the road. There is no force taking you off the road. The only thing taking you off the road is an absence of force. So we could say when there's no force keeping you on the road, then you'll slide off. So that deals with the first one. The second part, mower's back, pausing again. Okay, mower's gone again. Hopefully you can't hear that on this video, but driving me mad. You can be entertained by my madness. Anyway, less force keeping you on the road. That's kind of true, but the force that they're talking about keeping you on the road is not the centripetal force, which is helping you to turn the corner to change direction. So it's partially accurate that there is less force, and once you start slipping, there'll be less force because the kinetic friction is much lower than static friction. So you've got no hope of regaining ground once you start friction to turn you the corner once you start sliding. And the mower's back, so I'm going to finish there in 5 minutes is a good time.